Good day everyone. Today, me, Mr. Valentino and Mr. Deliquiña are going to discuss a certain topic entitled Pythagorean Triads or Pythagorean triples. So, this topic is very important to us, and it is very important because it is our last and final requirements for the subject Mathematics Advancement. So, before we start the main issue of this certain topic, first, let's discuss the meaning of Pythagorean triads. So, Pythagorean triads is a set of any positive integers a, b, and c, which is a squared plus b squared is equal to c squared. Then, how are we going to find Pythagorean triads? So, this is the explanation if how are we going to discuss the Pythagorean triads, or how are we going to find the Pythagorean triad. We can find Pythagorean triads if you square each numbers, subtract one square from a square greater than it, then square root this number, you can find Pythagorean triples. And if the result is a whole number, the two positive numbers and the square rooted numbers make up a Pythagorean triples. The main issue for this certain topic is we're going to look the statement of the problem for Pythagorean triads, look the pattern of Pythagorean triads, we're going to investigate the conjecture, make the conjecture, and all those is going to discuss by me, Mr. Valentino, and Mr. Deliquiña. So, what are we waiting for? Let's start the discussion for this certain topic. So, first issue is a statement of the problem. Under statement of the problem, we're going to tackle some example of Pythagorean triples. Then we're going to verify Pythagorean triples using Pythagorean formula. Then after verifying, we're going to investigate. So there are some example of Pythagorean triples. First is 3, 4, and 5. Next is 6, 8, and 10. Then 5, 12, and 13. So first example, to verify 3, 4, and 5 Pythagorean triples, we're going to use the formula of Pythagorean, which is a squared plus b squared equals to c squared. So for a squared, we're going to substitute 3 for a squared, 4 for b squared, and 5 for c squared. So 3 raised to 2 is 9, 4 raised to 2 is 16, and 5 raised to 2 is 25. 4 plus 16 is 25. Then it is true that 3, 4, and 5 is a Pythagorean triples because 25 is equal to 25. Another example is 6, 8, and 10 triangle. So for this example, we're going to use another formula, which is c square root of b squared plus b squared. So c minus square root of 6 squared plus 8 squared, then c minus square root of 36 plus square root of 64, which is c is equal to square root of 100. Then if we square root of 100 is 10. So the another example is 5, 12, and 13 triangle. So in getting the Pythagorean triples, the same formula is being used, which is a squared plus b squared equal to c squared. When it is equal, so next is investigate Pythagorean triples. So based on our investigation, we found out that in a Pythagorean triples, say that 3, 4, and 5 triangle, if multiplied by a common number, it will also result to another Pythagorean triples. When we say 3, 4, and 5, multiplied by 3, then the result will be Pythagorean triples also. So
The next step on making a mathematical investigation is on letter B, which is exploring the investigation. Based on our investigation, we have found out that in a Pythagorean triple, say 3, 4, 5 triple, if multiplied by a common number, it will also result to another Pythagorean triple. Example, 3, 4, 5 triple is multiplied by 3. 3 times 3 is equal to 9. 4 times 3 is equal to 12. 5 times 3 is equal to 15. The result is 9, 12, and 15, which is also a Pythagorean triple.
Gather and record data. Let us prove the investigation by using different numbers to multiply on the given Pythagorean triples. We will see if the result of the given Pythagorean triples multiplied by number is also a Pythagorean triple. Let us look at the given Pythagorean triple 3, 4, 5 multiplied by 2. This will become 3 times 2, 4 times 2, and 5 times 2. The result will be 6, 8, 10. Let us prove if this result is also a Pythagorean triple by using the Pythagorean formula a squared plus b squared equals c squared. Let a equals 6, b equals 8, and c equals 10. Evaluate. This will become 6 squared plus 8 squared equals 10 squared. Then simplify. We will have 36 plus 64 equals 100, or 100 equals 100. As we can see, the result is also Pythagorean triples. Let's take another example. Given the Pythagorean triples 6, 8, 10 multiplied by 3. Doing the same process with the first example, we got 18, 24, and 30. Using the Pythagorean formula, let us prove if the result is also Pythagorean triples. Let a equals 18, b equals 24, and c equals 30. Evaluate. It will become 18 squared plus 24 squared equals 30 squared. Then simplify. We will now have 324 plus 576 equals 900, or 900 equals 900. As we can see, the result is also Pythagorean triples. Let us explore the investigation by taking one more example. Given the Pythagorean triples 5, 12, 13 multiplied by 4. Following the same process with the previous examples, the result will be 20, 48, and 52. Let us prove using the Pythagorean formula if the result is also a Pythagorean triple. Let a equals 20, b equals 48, and c equals 52. Evaluate the formula. It will become 20 squared plus 48 squared equals 52 squared. Then simplify. We will now have 400 plus 2304 equals 2704, or 2704 equals 2704. The result is also a Pythagorean triples. After taking all of these examples, we can conclude that any Pythagorean triple multiplied by any common number will also result in other Pythagorean triples.
look for patterns. So in Pythagorean triads, we discover that the pattern is geometrically if one Pythagorean triple is a multiple of another, then the corresponding triangles are similar. So for example is 3, 5, and 6. So the multiple of 3 is 6, multiple of 5 is 10, multiple of 4 is 8. So the pattern will be 3 pairs of corresponding sides of 2 triangles are proportional, then the true triangles are similar. If For example, if EB over YZ minus BZ over ZY minus EC over XY, then triangle EBC is similar to triangle YZX. So here's the example. So for clarification, 3, 5, and 4, and 16 and 8. So 3 over 6 is multiple 2. 4 over 8 multiple 2. 5 over 10 multiple 2.
The prior step is followed by letter E, which is making a conjecture. In our investigation, we have stated two conjectures. First is, in a Pythagorean triple, say 3, 4, 5 triple, if multiplied by a common number, it will also result to another Pythagorean triple. Second, in a Pythagorean triple, say 3, 4, 5, and 6, 8, 10 triples, if one Pythagorean triple is a multiple of another, then the corresponding triangles are similar.
Gather more data to test the conjecture. To test the conjecture, let's take a look at the given examples. As what we have learned in the previous presentation, the results of the Pythagorean triples multiplied by any common numbers are also Pythagorean triples. Look at the Pythagorean triples 20, 21, 29, 7, 24, 25, and 10, 24, 26. They are multiplied by any common numbers like 2, 3, and 4. Their results are 40, 22, 58, 21, 72, 75, and 40, 96, 104, which are also Pythagorean triples. It was mentioned in the conjecture that if two Pythagorean triples, say 3, 4, 5, and 6, 8, 10, if one of them is a multiple of another, then the corresponding triangles are similar. Since the Pythagorean triples 40, 42, 58 is a multiple of 20, 21, 29 multiplied by 2, the corresponding triangles are similar, as you can see in the presentation.
Revise the conjecture. So if a Pythagorean triple is multiplied by common multiple, then the result will always be a Pythagorean triple. So in short, if 3, 4, and 5, for example, is being multiplied by some common multiples, for example 3, the result for the Pythagorean triples, which is 3, 4, and 5, is also 3, 4, and is also a Pythagorean triple. Next is, if one Pythagorean triple is multiple of another, then corresponding triangles are similar. For example, 8, 15, and 17. If we multiply it by another, then the next triangle is similar to the first triangle.
The next step in our mathematical investigation regarding Pythagorean triads is verifying the conjecture. We have used two triangles to verify our conjectures. So first we have 8, 15, and 17 triangle, and 9, 12, and 15 triangle. In 8, 15, and 17 triangle, we have multiplied the triangle by 3, 4, and 5. In letter A, we have multiplied the triangle by 3. So the result is 24, 45, and 51, which is also a new Pythagorean triple. We also have stated the proof using the Pythagorean formula. Another verification that we have used is multiplying the triangle 9, 12, and 15 by 3, 4, and 5.
Organized data. A Pythagorean triples consists of three positive integers a, b, and c such that a squared plus b squared equals c squared. Take note, when the sides of the triangle are Pythagorean triples, it is a right triangle. Therefore, the Pythagorean triple are only found in a right triangle. Take a look at the table below consisting the Pythagorean triples. They are all found in a right triangle. The table shows the values obtained for the multiples of Pythagorean triples. The Pythagorean triple 3, 4, 5 multiplied by 2, we got 6, 8, 10. If we multiply 3, 4, 5 by 3, we got 9, 12, 15. If we multiply 3, 4, 5 by 4, we got 12, 16, 20. If we multiply 3, 4, 5 by 5, we got 15, 20, 25, and so on. The following tables shows the similarity between triangles. As you can observe, these triangles are all right triangle. Generalization. The Pythagorean theorem in algebraic term is in the form a squared plus b squared equals c squared, where a is the base, b is the altitude, and c is the hypotenuse. As per verification, it has been proven that if a Pythagorean triple is multiplied by a common multiple, then the result will always be a Pythagorean triple. As per investigation, the pattern observed, it has been proven that if one Pythagorean triple is a multiple of another, then the corresponding triangles are similar. These concepts of Pythagorean triples can be used in solving various mathematical problems regarding triangles.